Welcome back. We're going to look at the law of sines with the ambiguous case now. Remember, this is the side-side angle. So here's the idea. We know a side, we know another side, and we know an angle, but the angle is not the one that's between those two sides. It's over here. So you can think of this pink side right here as just kind of swinging freely in the wind. And we want to see if we can make a triangle out of this with this dotted line base. Now in the picture that I've got, you can see that it's too short. So we may not get a triangle at all. On the other hand, got my angle here. This might be long enough to make a triangle. But there's another case that could happen. Let me draw it over here. And if this case is a little bit longer, you can see I'll make a triangle, but that could also swing around over here where I have two triangles. One triangle would be, let me mark it, would be this pink triangle, and the other triangle would be this little blue triangle right here. So there would be two possible answers. Okay, so here's how we're going to do this in this case. Here's how we're going to solve this. Find your first angle. And then there are going to be two possibilities. The angle that you found, or 180 degrees minus that. So that's going to give you two possible triangles. You're going to work them through. If you can solve the problem, then you're going to have two answers. So work as normal. Unless problem is impossible to solve. And here's what I mean by that. Let me write this first. Here's what I mean by that. That's if you end up having to solve inverse sine of something bigger than 1. In that case, you can't get an answer. Your calculator will give you an error. They can't take in the inverse sine of anything that's larger than 1. So in that case, that leads you to a dead end, and that part of the solution would be impossible. Now I'm going to do a couple of examples so that we can see how this works. Okay, oops. And I'm pulling these from Alex, so let's take a look. So here's a triangle that we've got. Little b is equal to 54, little a is equal to 26, and big B is equal to 100. So I've got side-side angle here. So I know this is the ambiguous case. So I'm going to start to solve the triangle. All right, I'm in a situation where I know an angle and the opposite side, so I'm going to proceed with law of sines. So I'm going to take sine of 100 over 54 equals, well, I only know one other side, that's the 26, so that would go with sine of A. So I'm going to solve for sine of A. 26 times sine 100 over 54 equals sine of A. And to solve this, I have to take the arc sine, the inverse sine of each side. So sine inverse of 26 times sine 100 over 54 equals sine inverse of sine of A, and those will cancel. And so what do I get for A? Oh my gosh. Sine inverse, I am in degrees, sine inverse of 26 times sine 100 divided by 54 is 28.3, and they want 4 decimal places, 28.3051. But remember what I have to do. I have to take that or 180 minus that. So if I subtract that from 180, I get 151.6949. So it looks like there are two possible triangles. Let's take a look and see what that would be. I'm just going to copy this guy. And I'm going to paste it in here twice. One possibility is the 28.3051. The other possibility is the 180 minus that, which would be 151.6949. Okay. So now I just keep proceeding, except I have two possible triangles. So this is possible number 1, and this is possible number 2. So let's see. I know two angles now, so I can get the third angle. So that's what I'm going to go after next. So angle C is 180 minus 100 minus 28.3051. I'll calculate that out. 180 minus 100 minus 28.3051. So this would be 51.6949. That's one possibility for angle C. For angle number 2, let's see what angle C should be. 180 minus 100 minus 151.6949. So let's calculate that out. 180 minus 100. Some of you know what's going to happen. I'm playing dumb. 151.6949, negative number. That means that this triangle, triangle 2, is not possible. I only have one triangle. And so I would continue on and solve for my one triangle. Over here, I would just stop. Okay. If both of these triangles worked out, then I would continue through and I would have two possible answers in that case. So that's what's going to happen. You're going to get something that doesn't make any sense at all. Either you're going to take the inverse sine of something that's larger than 1, or you're going to have angles that are too big to add up. So let's look at another example. I'm going to flip through Alex and find one that would be good. Hold on a second. Okay, here's another triangle, another situation. So let me draw the triangle. A, B, B, and C, C. And what do we know? C is 15. Little a is 18. And big C is 33 degrees. So again, I have side-side angles, so I think this may be an ambiguous case. know this angle and this side, so I'm going to start with that. And I only know one other piece, so I'm going to put that one in, and that's A, so I'm going to have sine of A right here. So 18 times sine of 33 degrees all over 15 equals sine of A, and I'll take the inverse sine of each side. And here they cancel. And here I have a bunch of calculating. So inverse sine of 18 times sine 33 divided by 15 is 40.8111. But again, because this is the ambiguous case, I also have to take 180 minus 40.8111. And when I do that, I get 131.1889. So I've got two possible triangles. Again, I'm going to cut this guy out. I'm going to copy him twice. That was a 15 on the left. And my two possibilities for triangle A were 40.8111. And the other one was 139.1889. So now I continue on in my two parallel universes. So I try to get angle B. In this case, I know C and A. So B is going to be 180 minus 40.8111 minus 33. Let's see what that is. So 106.1889. And over here, in this parallel universe, B would be 180 minus 33 minus 139.1889. And let's see what that is. And this time I get B is 7.8111. So this is where I have two triangles. So I would continue down and solve this one. I would continue down and solve this one. So I would have two possible solutions to that triangle. I'm going to look and see if I can find one where there's no triangle so you can see what happens in that case. Hold on. Okay, here's one final example. Okay, so I've given two sides and an angle. B equals 8, A equals 15, and angle B equals 105. Again, it's side-side angle, so I have to use law of sines. Okay, I know this angle. Come on, green. I know this angle and this side, so that's what I'm going to start with. Sine 105 divided by 8 equals, let's see, little a is the only one I know, so there's my 15, and sine of a goes right there, and I'll solve for a. 15 times sine 105 divided by 8 equals sine of a, so I'll take inverse sine of each side. And on this side, they cancel. And now I get inverse sine of 15 times sine 105 divided by 8. And I'm getting an error. Okay. Now, some of your calculators may work with complex numbers. If you get a complex number, that's the same as an error in this case. So be sure that you're not just getting a complex number in your answer. If your calculator works with those, look at it and be sure. If you get a complex number, you're going to just treat it like an error, because complex analysis is something that you do as an upper level math major. Okay, so we've got an error. Since we've got an error right here, this is the case where there are no triangles. I couldn't even get the first angle. So this would be a no solution in this case. So those are the three cases for the ambiguous case. For side-side angle, you're going to use law of sines in that case. And that is it for this week. Remember to answer the discussion question, and I'm looking forward to seeing you again when we come back on Tuesday to get ready for the exam. Bye-bye now.